Hey guys, welcome back to a new video. In this video I will give you an overview over these typical observables we have in Android, like live data, state flow, normal flow, shared flow, compose state, because all these are quite similar, but they differ in some minor aspects. And I want to show you in this video, and I want to give you more clarity over this topic, how you actually can use these in your project, and especially for which scenarios you should use which. So by making sure that you watch this till the end, you also make sure that you actually won't have many more questions around this topic, and you actually know when to use these things. As you can see, I created a little demo app here to actually show you the differences. Right now this app doesn't do anything, I just have some initial setup. Just to show you, we just have 4 different of these observables here. Live data, state flow, normal flow, and shared flow. And there's also compose state, which I can't use here because it's an XML project. It's just better to demonstrate this in an XML project, but most of these also can be used in compose projects. So all that happens here is, or that I want to happen, when we click these buttons, then right now nothing happens, but we actually make a call to our view model that triggers, in this case, a live data that should change the value of this text. Here we trigger a state flow that changes the value of this text, your normal flow, and a shared flow. So just that I can show you the differences of these different observables. But right now we don't observe anything here, so nothing in our UI changes. I just implemented these functions here to trigger the view model functions, which you can see here. So let's actually go through this step by step. I will show you how you can observe these values, how you can create these objects, starting with the live data actually. I think live data will be the most well-known observable pattern here that we have in this list, because it's just the oldest. It belongs to the Android Jetpack components and is actually also the only one that works on Java here. So in Java projects you have to use that. I hope you don't use Java anymore for Android, but if you do, you have to use live data. So what does it do? Live data is a so-called state holder. So it holds our UI state in the end. If any value in your UI changes over time, then that change, so for example the new string that should be reflected here in our UI, that needs to be stored somehow, because otherwise it will be lost on screen rotations. And that's what live data does. So you can put the state in live data, and when the activity rotates, all the observers will automatically be notified about the current value. So you can see when we trigger live data here, we just change the value to live data. Let's see how that works when we want to observe that in main activity. Here in subscribe to observables. It's important to mention that live data is actually lifecycle aware, so it will only fire off the new value or the current value if the corresponding lifecycle is actually in a state where it should receive these, that data. Like if the activity is in the foreground basically. So we want to say view model, live data, and we say observe. So that will now be called whenever there is a change on the live data value. We need to pass a lifecycle owner. Here we just pass this because it's the activity. If you have that in a fragment, you use view lifecycle owner instead. But since we don't have that, we pass this. And then in here, you can see we get a string, which is the new value of that live data. We can just say we use our binding, our text view live data, and we set the text to whatever we got from the live data. If we then relaunch our app to show you a little demo of how that works, then you can see if we now click on live data here, then we will trigger the event in our view model here. We will assign a new value to our live data, which is this. So this live data now holds live data as a string and not hello world anymore. This, because we made the change, will then trigger the observer here, this block, and we change the text to whatever is in the live data. And the thing about live data is now if we rotate our device, it will automatically fire off again. So you can see it keeps the value and the text won't be hello world again. So far so good. Let's get to state flow and how it compares to live data. A state flow, as the name already suggests, also holds state, as well as live data. So it's also just a state holder class. However, it's a little bit different than live data. State flow, as the name also says, is a flow. So if you know Kotlin flows, I will get more into this in this video here, then a flow is basically comparable to live data, but it can actually do a little bit more. So in regards to state flow, this is very similar to live data. I will get to the other flows here in a moment. But the state flow is the most comparable one to live data because it's used to also store state. And it is basically a flow. So we have the flow benefits, which I will get to in a moment. You can see we can change the state flow value exactly the same way as here for live data. And then to actually be able to observe from that, we actually need to do that in a coroutine, because a flow is based on the coroutine framework in Kotlin. So we need to launch a coroutine here in lifecycle scope, which is lifecycle scope launch when started. Always use launch when started here, never use launch to collect from a state flow. And here we say view model, state flow, collect latest, and that's basically now the equivalent to this. So this will now be fired off every time the state flow value changes. So in here we can say binding tv state flow dot text is equal to it. And if we relaunch this, you will see it will have the exact same behavior as our live data here. So there we go. You can see if we click live data and state flow, both these values change. And if we rotate the screen, then both these values here will actually stay in the corresponding text views. So the state is just kept, which is exactly the job of a state holder class. So which of these two should you actually now use? So in the end, they do the same thing. So which should you actually use in your projects? I personally recommend not using live data anymore because it's just kind of obsolete, and the flow, the state flow version just can do a little bit more with actually now the screen. Then both these values here will actually stay in the flow dot text is equal to it. And if we relaunch this, you will see it will have the exact same behavior as our live data here. So there we go. You can see if we click live data and state flow, both these values change. And if we rotate the screen, then both these values here will actually stay in the corresponding text views. So the state is just kept, which is exactly the job of a state holder class. So which of these two should you actually now use? So in the end, they do the same thing. So which should you actually use in your projects? I personally recommend not using live data anymore because it's just kind of obsolete, and the flow, the state flow version just can do a little bit more. With state flow, we have all these powerful flow operators, which you might know. You can map the results easily, you can filter them, and also flows are much easier testable actually than live data because they use coroutines. The testing capabilities for coroutines are great because you can test time in the end very easily, because for test cases the delay of coroutines are just skipped. So yeah, personally I always use state flow in my projects, assuming it's not a composed project, just a normal XML one. Then I always use state flow. It's just better than live data. Get used to it, it's great. Something that's also worth mentioning here is that there are hot flows and there are cold flows. State flow is a so-called hot flow, and that means that it will keep emitting values even if there are no collectors. A cold flow would mean it would not emit anything if there is no collector. So you can see this would be a collector here, and even if we wouldn't have that, and we change the value here of state flow in our view model, the state flow would still emit something even though there is nobody to collect that. So that's just worth mentioning here because we will also get to some cold flows in this video. So the next observable here that I want to show you is just a normal flow. You can see I don't have that here in the view model really, I mean not as a variable. Instead we have this function trigger flow which returns a flow. And we have to do it like that because that is how normal flows work. We have to construct these flows with this flow builder here, and then inside of this flow builder we have a coroutine scope in which you can execute suspend functions, as you can see. And with this emit function, we can say, now I want to emit a value and trigger our observers. So the normal flow doesn't work like state flow in the way that we can say flow.value is something because it doesn't hold a value. Instead, it just does something. And while it's doing something, it can emit different values over a period of time. So all that flow does here is it repeats the block here 5 times. It will emit a string that gives us the current iteration, delays the flow for a second, and then just does that 5 times basically, leading to 5 emissions in total, and after that it will just be cancelled or will just quit. So we can actually subscribe to that the same way we do for state flow because both are flows. We don't do that here in subscribe to observables because we want to trigger that when we actually click on the button. So here, that now returns that flow, and we can say that collect latest, which will also give us these strings. Don't forget to do that in lifecycle scope. That launch. Here we can actually use launch because it's not a state flow. And here we simply want to say binding TV flow text is it. If we now relaunch this, then you will see how that now works. So while these two here were state holder flows or live data, the flow one, the normal flow, will now work a little differently. So if we click that, you can see we get the emission 0, 1, 2, 3, 4, and after that the value will just stay in the text view because the flow actually finished with its 5 repetitions. However, if we now rotate the device, you see live data and state flow stays there, but the flow one actually changes back to hello world because the normal flow does not contain a state. So it doesn't just fire off something again when the activity is actually recreated. Instead, it's more like a one-time thing. So when we trigger the flow, we can do that again. Then it will just create that new flow and emit these values over time. And when it's done, it's done. Then the flow is done. Last but not least, I'll get to shared flow. And actually compose state, that's a little bit differently than all of these. But shared flow is actually also flow, surprise, surprise. And you can see we can construct it in a similar way than we can state flow. We don't provide an initial value here because a shared flow, just as a normal flow, does not keep a value in itself. It's the same as a state flow in the sense of that it's also a hot flow. So shared flow and state flow are both hot flows, so they will send out events. But shared flow is actually also flow, surprise, surprise. And you can see we can construct it in a similar way than we can state flow. We don't provide an initial value here because a shared flow, just as a normal flow, does not keep a value in itself. It's the same as a state flow in the sense of that it's also a hot flow. So shared flow and state flow are both hot flows, so they will send out events, or they will send out new data or events, even if there are no collectors. But what is the difference now? Well, a shared flow is more used to send one-time events, because let's take the typical example in Android of showing a toast or a snack bar. Let's say you would actually trigger a state flow when you actually want to show a snack bar. That would mean that here, where we actually observe that, we can actually do that to demonstrate that. I think that that makes it clearer. Let's say here we want to show snack bar, snackbar.make, we can say binding.root, and we can say it, snack bar length long, and show. So whenever the state flow triggers, we want to show snack bar. And let's say we get some kind of event in the view model. Let's say we get an API response that was an error, and we now want to show that error in our UI. So what we do is, in the view model, when we know there is an error, we say our state flow value is that error, or whatever. And if we now relaunch that and take a look, then if we now click state flow, you can see we just get a snack bar with a state flow. If we do that again, we don't get it because it actually keeps a value and it won't emit the same value again. However, if we now rotate the device, you can see the snack bar shows up again because that's the behavior of state flow. It will automatically emit the value when the activity is actually recreated. And that's usually not what you want with snack bars. So they should actually just show up once and that's it. Even if there are screen rotations in future, you don't want to show that error snack bar over and over again. And that is now where a shared flow comes into play, because it just sends out a one-time event that isn't re-emitted on screen rotations. So if you take a look, we can trigger the shared flow by using a coroutine here and just calling emit. So it's similar to a normal flow, just that we can call this emit function outside of the flow kind of. So we don't need this flow builder where we construct how the flow works once and then it just works that way. Instead, we can just say somewhere in our view model, we now want to send an event into this flow. And then let's actually go back to main activity, and I'll just change this to shared flow here for convenience, because I think state flow should be pretty clear now. Relaunching this, and if we now click on shared flow, you can see we see a snack bar. If we rotate this, we don't see a snack bar, but we can still click here to see another one, and so on. So it's just used to send out one-time events when a specific user action happens, or when you get an API response, something like that. It's also very helpful, for example, if you do something in your view model and validate something, and based on this validation, you might want to navigate to a different screen. So then you can say from the view model, if the validation or whatever is successful, you just emit an event. You can create some kind of event class here that says navigate. You could even pass a route where you want to navigate. And then here in your activity or fragment, when you receive that navigation event, you know, okay, now the view model actually sent me that event and I should now use my nav controller to navigate to that corresponding page. So while the normal flow is more used to, if you have some kind of logic that, emits multiple values over a period of time. So I would say a flow is just a coroutine that can emit multiple values. While a coroutine, just a normal suspend function, can only return a single function when it's done, a flow can emit these values. So it doesn't need to say return that value. It can say emit. It can use suspend functions to delay these emissions to send these at different times. So if you need that behavior, use a normal flow. And if you need this behavior to send events from somewhere in your view model to your UI, then you want to use a shared flow. So something I used a normal flow for was, for example, a timer. So you could say repeat for, let's say, 60 seconds. You delay that for a second, and every second you just make an emission. You can collect that emission in your UI, and you can actually display that. So that would already be a very simple 60-second timer here, where you say, we just emit it. Maybe it plus 1 here, because it starts at 0, would then be a flow of integers. But that would basically start the flow. It would emit the corresponding second every second, and then you can observe on that in your UI, and you already have a working timer. So that's what the normal flow is really cool for. And then lastly, I want to talk a little bit about the compose state, because it kind of belongs in this list here, but it's not really the same as a flow or a live data. It is the same in the sense that it's also a state holder class. It's just called state in compose, but it works quite differently, because in Compose, we have to use that. So we are forced to use it. Or if you use a state flow, then there is a function to actually call, I think it's collect as compose state or so. And lastly, I want to talk a little bit about the compose state because it kind of belongs in this list here, but it's not really the same as a flow or a live data. It is the same in the sense that it's also a state holder class. It's just called state in Compose, but it works quite differently because in Compose, we have to use that. So we are forced to use it. Or if you use a state flow, then there is a function to actually call, I think it's collect as compose state or so, to convert that to compose state. But in the end, in your UI, you have to use these compose states. The reason for that is that the compose framework is built in a way that whenever these compose states change, the composables that are affected by this change will actually recompose and will be redrawn so that the actual change is reflected in your UI. So yeah, what I'm trying to say is whenever you use Jetpack Compose, you want to use the compose state. If you use XML, then I suggest using all these flow versions here of these observables. So don't use live data anymore. Use a state flow if you want to save state. Use a shared flow if you want to send events to your UI, and use a normal flow if you just have some logic and you want to emit multiple values over a period of time. So I hope this video was helpful for you and it actually helped you to understand these concepts and also the differences between these. If so, then you will definitely also love my free email newsletter in which I regularly talk about Android architecture, about Kotlin, Android advice. So feel free to click the link down below and subscribe for that email newsletter for free. Thanks again and have an amazing day. See you in the next video. Bye bye.
Hi everyone! Today, Jose and I want to bring the reactive programming concept close to Android development. Then we'll see how to work with Flow, Kotlin type for modeling streams of data. As Android has a particular UI lifecycle, we'll see how to optimize flows for things like rotations and sending the app to the background. And lastly, as with all good stories, we need to test that everything works as expected.
Every Android app needs to send data around one way or another, and there's a million different use cases. Loading a username from a database, fetching a document from a server, authenticating a user. In this talk, we'll look at how you can load data into a flow, transform it, and expose it to a view so that it's displayed. To help me explain why we use Flow, here's Pancho. Pancho lives on a mountain. And when Pancho wants fresh water from a lake, they do what any beginner would do. They grab a bucket and walk up to the lake and down again. But sometimes Pancho finds that the lake is dry, so they wasted time walking up to the lake as they have to find water elsewhere. After doing this multiple times, they realize it would be much better to create some kind of infrastructure. So the next time they walk up to the lake, they install some pipes. Now, if they need more water and the lake is not dry, they just open the tap. Once you know how to install pipes, it's easy to get fancy and combine multiple sources of water, so that Pancho doesn't have to check if the lake is dry anymore. In an Android app, you can take the easy path and request data every time you need it. For example, when the view starts, you request data to a view model, which in turn requests data to the data layer, and then everything happens in the other direction. You can do this easily with suspend functions. However, after doing that for a while, developers like Pancho tend to realize investing in some infrastructure really pays out. Instead of requesting data, we observe it. Observing data is like installing tubes for water. Once they're in place, any update to the source of data will flow down to the view automatically. You don't have to walk to the lake anymore. We call a system that uses these patterns reactive, because observers react automatically to changes in the things being observed. Another important design choice is to keep data flowing in just one direction, as this is less prone to errors and easier to manage. In this example app, the auth manager tells the database that a user logged in, and this one in turn has to tell the remote data source to load a different set of items, all of this while telling the view to show a loading spinner while they grab new data. I mean, this is doable, but prone to bugs. A better way to do this is to let data flow in just one direction and create some infrastructure, some tubes, to combine and transform these streams of data. If something changes that requires modifications, such as when the user logs out, the tubes can be reinstalled. As you can imagine, we need sophisticated tools to do all these combinations and transformations, and in this talk, we're going to use Kotlin Flow for that. It's not the only streams builder out there, but it's part of coroutines and very well supported.
The stream of water analogy we've been using so far can be modeled in a concrete type called flow, a type that is part of the coroutines library. Instead of water, flows can be of any type T, for example, user data or UI state. There is some terminology we'll be using during the talk that is important to define. A producer emits data into the flow that a consumer collects from the flow. In Android, a data source or repository is typically a producer of application data that has the UI as the consumer that ultimately displays the data on screen. Let's start with how flows are created. For that, let's take a walk to the lake. Most of the time, you don't need to create a flow yourself. The libraries you depend on in your data sources are already integrated with coroutines and flows. This is the case of popular libraries such as Data Store, Retrofit, Room, or Work Manager. They act like a water dam. They provide you data using flows. You just plug into a pipe without knowing how the data is being produced. Taking Room as an example, you can get notified of changes in the database by exposing a flow of type X. The Room library acts as a producer and emits the content of the query every time an update happens. If you really need to create a flow yourself, there are different alternatives you can choose. One of the options is the Flow Builder. Imagine that we are in a user messages data source and you want to check for messages every so often from your app. We can expose the user messages as a flow of type list of messages. To create a flow, we use the Flow Builder. The Flow Builder takes a suspend block as a parameter, which means it can call suspend functions. And this is because the flow is executed in the context of a coroutine. Inside it, we can have a while-true loop to repeat our logic periodically. First, we fetch the messages from the API, and then we add the result into the flow using the emit suspend function. This step suspends the coroutine until the collector receives the item. Lastly, we suspend the coroutine for some time. In a flow, operations are executed sequentially in the same coroutine. Due to the while-true loop, this flow keeps infinitely fetching the latest messages until the observer goes away and stops collecting items. Also, the suspend block passed to the Flow Builder is often called producer block. In Android, layers in between the producer and consumer can modify the stream of data to adjust it to the requirements of the following layer. To transform flows, you can use intermediate operators. If we consider the latest messages stream as the flow starting point, we can use the map operator to transform the data to a different type. For example, inside the map lambda, we are transforming the raw messages coming from the data source to a messages UI model that is a better abstraction for this layer of the app. Each operator creates a new flow that emits data according to its functionality. We can also filter the stream to get a flow for those messages that contain important notifications. Now, how can we handle errors that happen as part of the stream? The catch operator catches exceptions that could happen while processing items in the upstream flow. The upstream flow refers to the flow produced by the producer block and those operators called before the current one. Similarly, we can refer to everything that happens after the current operator as the downstream flow. Catch can also rethrow the exception if needed or emit new values. For example, this code rethrows illegal argument exceptions, but emits an empty list if any other exception occurs. At this point, we've seen how streams are produced and how they can be modified. It's time to learn about how to collect them. Collecting flows usually happens from the UI layer, as it is where we want to display the data on the screen. In our example, we want to display the latest messages on a list so that Pancho can keep up with what's going on. We need to use a terminal operator to start listening for values. To get all the values in the stream as they are limited, use collect. Collect takes a function as a parameter that is called on every new value. And as it is a suspend function, it needs to be executed within a coroutine. When you apply a terminal operator to a flow, the flow is created on demand and starts emitting values. On the contrary, intermediate operators just set up a chain of operations that are executed lazily when an item is emitted into the flow. Every time collect is called on user messages, a new flow, or pipe, will be created, and its producer block will start refreshing the messages from the API at its own interval. In coroutines jargon, we refer to this type of flows as called flows, as they are created on demand and emit data only when they are being observed. Let's see now how to optimally collect flows from the Android UI. There are two main things to consider. The first one is about not wasting resources when the app is in the background, and the second one is about configuration changes. Let's imagine we are in messages activity and we want to display the list of messages on the screen. For how long should we be collecting from the flow? The UI should be a good citizen and stop collecting from the flow when the UI is not displayed on the screen. Back to the water analogy, Pancho should close the tap while brushing their teeth or going for a nap. Pancho shouldn't be wasting water. Similarly, the UI shouldn't be collecting from flows if the information isn't going to be displayed on the screen. To do this, there are different alternatives, and all of them are aware of the UI lifecycle. You can use live data or lifecycle coroutine-specific APIs such as repeat on lifecycle and flow with lifecycle. The asLiveData flow operator converts the flow to live data that observes items only while the UI is visible on the screen. This conversion is something we can do in the viewModel class. In the UI, we just consume the live data as usual. But OK, this is cheating a bit because it's adding a different technology into the mix, which shouldn't be needed. Repeat lifecycle is the recommended way to collect flows from the UI layer. RepeatOnLifecycle is a suspend function that takes a lifecycle state as a parameter. This API is lifecycle aware as it automatically launches a new coroutine with the block passed to it when the lifecycle reaches that state. Then, when the lifecycle falls below that state, the ongoing coroutine is cancelled. Inside the block, we can call collect as we are in the context of a coroutine. As RepeatOnLifecycle is a suspend function, it also needs to be called in a coroutine. As we are in an activity, we can use lifecycle scope to start one. As you can see, the best practice is to call this function when the lifecycle is initialized, for example, in onCreate in this activity. RepeatOnLifecycle's restartable behavior takes into account the UI lifecycle automatically for you. Something important to notice is that the coroutine that calls RepeatOnLifecycle won't resume executing until the lifecycle is destroyed. So, if you need to collect from multiple flows, you should create multiple coroutines using launch inside the RepeatOnLifecycle block. You can also use the flow with lifecycle operator instead of RepeatOnLifecycle when you have only one flow to it in this activity. RepeatOnLifecycle's restartable behavior takes into account the UI lifecycle automatically for you. Something important to notice is that the coroutine that calls RepeatOnLifecycle won't resume executing until the lifecycle is destroyed. So, if you need to collect from multiple flows, you should create multiple coroutines using launch inside the RepeatOnLifecycle block. You can also use the flow with lifecycle operator instead of RepeatOnLifecycle when you have only one flow to collect. This API emits items and cancels the underlying producer when the lifecycle moves in and out of the target state. To show how this works visually, let's take a tour through the activity lifecycle when it's first created, then sent to the background because the user pressed the home button, which makes the activity receive the onStop signal, and then opening the app again when onStart is called. When you call RepeatOnLifecycle with the started state, the UI processes flow emissions while it's visible on the screen, and the collection is cancelled when the app goes to the background. RepeatOnLifecycle and flow with lifecycle are new APIs added in the stable 2.4 version of the Lifecycle Runtime KTX library. Because they are new, you might be collecting flows from the Android UI in a different way. For example, you might be collecting directly from a coroutine launched by Lifecycle Scope. While this might seem okay to use, collecting flows in this way is not always safe. This collects from the flow and updates UI elements even if the app is in the background. In fact, this is not the only case. Other solutions like the Lifecycle Coroutine Scope LaunchWhenX API family suffer from similar problems. You don't like Pancho wasting water, do you? Then we shouldn't be collecting from the flow if those items aren't going to be displayed on the screen. If you collect directly from lifecyclescope.launch, the activity keeps receiving flow updates while in the background. That can be both wasteful and dangerous, as for example, showing dialogues when the app is in the background can make your application crash. To solve this issue, you could manually start collecting in onStart and stop collecting in onStop. While that's okay, using RepeatOnLifecycle removes all that boilerplate code. If we look at launch when started as an alternative, it is better than lifecyclescope.launch because it suspends the flow collection while the app is in the background. However, this solution keeps the flow producer active, potentially emitting items in the background that can fill the memory with items that aren't going to be displayed on the screen. As the UI doesn't really know how the flow producer is implemented, it is always better to play safe and use RepeatOnLifecycle or flow with lifecycle to avoid collecting items and keeping the flow producer active while the UI is in the background. If this optimizes flow collection when the app goes to the background, Jose is going to tell you some tricks for when the app goes through configuration changes.
When you expose a flow to a view, you have to take into account that you are trying to pass data between two elements that have different life cycles. And not any lifecycle, the lifecycle of activities and fragments, which can be tricky. As a crucial example, remember that when a device is rotated or receives a configuration change, all activities might be restarted, but a view model survives that. So, from a view model, you can't just expose any flow. For example, a call flow like this one. A call flow restarts every time it's collected for the first time, so the repository would be called again after a rotation. What we need is some kind of buffer, something that can hold data and share it between multiple collectors, no matter how many times they are recreated. Stateflow was created for exactly that. Stateflow is a water tank in our lake analogy. It holds data even if there are no collectors. You can collect multiple times from it, so it's safe to use with activities or fragments. You could use the mutable version of Stateflow and update its value whenever you want, for example, from a coroutine like in here. But that's not very reactive, is it? Pancho would suggest you improve your game. Instead, you can convert any flow to a state flow. If you do that, the state flow receives all the updates from the upstream flows and stores the latest value. And it can have 0 or more collectors, so this is perfect for view models. There are more types of flows, but this is what we recommend because we can optimize state flow very precisely. To convert a flow to state flow, you can use the state_in operator on it. It takes 3 parameters. Initial value, because the state flow always needs to have a value. A coroutine scope, which controls when the sharing is started. We can use the view model scope for this. And started, which is the interesting one. We're going to get to what that while subscribe 5000 means, but first let's look at 2 scenarios. The first scenario is a rotation, where the activity, which is the collector of the flow, is destroyed for a short period of time and then recreated. The second scenario is a navigation to home, where our app is put in the background. In the rotation scenario, we don't want to restore any flows to make the transition as fast as possible. In the navigation to home, however, we want to stop all flows to save battery and other resources. So, how do we detect which one is which? We do that with a timeout. When a state flow stops being collected, we don't immediately stop all the upstream flows. Instead, we wait for some time, for example 5 seconds. If the flow is collected again before the timeout, no upstream flows are cancelled. That is exactly what the while subscribe 5000 does.